Now in Learning Objective B, we're going to talk about the key vocabulary related to tangent, the domain, the range, where it's positive, negative, max, and mins, and the zeros. So again, as we look at the tangent function, we're going to notice here's the origin, and we see that this function goes like this, and then it's going to hit an asymptote at pi over 2. It's going to hit an asymptote at 270 degrees, or 3 pi over 2. And it's going to continue to have asymptotes, but this pattern keeps repeating itself with x-intercepts at 2 pi, 1 pi, 0 pi, and so forth. So let's talk about the domain. The domain on this graph, and if you travel and look at what I've done and traced in the blue, there is a domain issue with the tangent function. This is not a clean continuous function. It starts to graph right here, but has to lift up its pencil to continue to graph. So we have graph issues at these asymptotes. So the domain here is all real numbers, except where do we have the issues? Take a look. 1 pi over 2, 3 pi over 2, 5 pi over 2. So that's going to be all reals except the odd multiples of pi over 2. So letter C here is how we would state the domain. Now the range, remember, is the y's. So if you look at the height of this goes on towards positive infinity, and the range goes down to negative infinity. The range on this function is all reals. There's no limitation. Now let's just look at the tangent function again from 0 to 2 pi, or 0 to 360. So we'll just isolate it from here to here, and we're going to answer these questions about being positive and negative. The tangent function is positive, we can see from here and here. Well, if you think at the unit circle, by the way, where are the slopes positive? The slopes are positive in quadrant 1 and in quadrant 3. So we're going to say it's positive for the x values, not including 0 degrees, but up to 90 degrees. And then it's going to be here from 180 to 270 to 270. Again, I could state this in radians instead of degrees if I wanted to. It'd be pi over 2, pi, and 3 pi over 2. Now where is it negative? We see that this function is negative from 0 to 2 pi right here and right here. Well, the tangents are negative here in quadrants 2 and 4. So it's going to be negative from 90 degrees to 180. So we'll have the x's be from 90 degrees to 180 degrees. And then from here, 270 to 360. And be careful, we don't do is equal to on here, because here the slope is 0, here it's undefined, so we cannot include it. Now the max and the min on here, the maximum of this function, how high does it go? This thing goes to positive infinity. How low does the function go? This goes down to the minimum is negative infinity. Now where are the zeros of the function? The zeros of this function are going to happen here at the x-intercept there, there, and there. Now the values here are 0 pi, 1 pi, 2 pi. So the zeros happen at integer values of pi. Again, at 0, 1, 2, and so forth. Now the last thing I do want to talk about that's not on the screen is the period. Remember, the period of these functions is how long it goes in terms of its length until it repeats its pattern. Well, here's one complete cycle of tangent. This starts here, this one, at pi over 2, and it goes to 3 pi over 2. So what is the length of pi over 2 to 3 pi over 2? And then it starts over. It's 1 pi unit long. So the period of tangent is actually 1 pi versus 2 pi for sine and cosine. Now here's a good question back from chapter 3. Is tangent even, odd, or neither? Remember, what even means is it reflects over the y-axis. The odd means it rotates about the origin, about the ordered pair 0, 0. So if you look at tangent, if you look at one cycle of tangent here, if it were to reflect over the y-axis, what it would have to look like, its reflection would be like this. Clearly, that green graph I drew is not tangent, so this thing is not an even function. Now, if it were odd, what I would do is we would hold it steady at the origin, and we would take this red graph and we would rotate it. If we rotate it 180 degrees, it'll actually end up and become itself again. So this function does end up being odd. Now to prove it, if we wanted to, remember the test is, if we put in a negative theta for odd, we're going to get the opposite of the original. And let me just show you this. If I put a negative theta in for here, what you're going to get is y equals the tangent of negative theta. Now the opposites theorem that we learned actually said that the tan of the opposite angle is going to be equal to the negative tan of theta. Now you don't need to worry about having to prove this algebraically, but you do need to understand visually that this is an odd function.